As we begin our discussion of function transformations, I think it's important to first talk about what a transformation is, and then get into a sort of brief look at what we call the library of parent functions. So first and foremost, what a transformation is basically a function being changed in a certain way. And there are essentially like two different types of transformations as far as I can tell. There are transformations where we can slide things around. There are transformations where we can reflect things or flip them over. And I guess there are three types. There's a third type where they're being distorted or sort of changed or squeezed or stretched. So as we go through this presentation, we're going to be looking at functions that fall into like one of these categories on the screen here. These are what we call the parent functions, and these are basically where all of our, not all of our, but most of our other functions sort of stem from. So we can start over here, right? We have our constant function. That's in this case, we have y equals 1, right? And before I continue, I will sort of say that I'm recording this at school, and there's a little bit of background noise, so I apologize about that. But as we get over here, we have our, what we call our linear parent function. Here's our parabola, our quadratic function. Here's our cubic parent. Here's our absolute value. So these are all families of functions. This is our square root function. This is what it looks like normally. This is our cube root function. This is our logarithm function. This is our function where we're raising this number e to the x exponent. This is right here like a step function. Looks like a ladder or stairs, and it's formally called the greatest integer function. Here we have a rational function, a rational family, 1 over x. Then we get into our trig functions. We have our three main trig functions here. Sine, which goes to the origin. So these are trigonometric functions. Cosine doesn't go through the origin, it goes through 0, 1. And the tangent, as you can see, is very strange. There are these vertical asymptotes at regular intervals. So every function that we look at today is going to basically come from one of these parents. So what does it mean for a function to be transformed? Well, these are the different types of transformations. So we start up here with our parent, right? That's our regular root function. I'm just going to give you examples based off of that. All right, everything in this list here is based off of the square root function. So you can see that the first one adds a 4 onto the end, and that shifts up 4 units. When there's a -4 at the end, it's down 4 units. Notice both of these are outside of the square root symbol. When the number's inside the square root symbol, the radical, it moves left and right. If it's plus, it moves left, and that's not a typo. Plus means left. If it's minus, it moves right. If it's a negative out in front, it reflects down, so it'll look like this. If there's a negative underneath, it is reflected left, so it'll look like this. If there's a number out in front that's bigger than 1, it's going to be vertically stretched, so it'll be a little bit taller. If there's a number out in front that's a fraction in between 0 and 1, it's going to be squished vertically. It's going to be shorter than it normally is. Alright, so if our parent square root function looks like this, if we shift things up, up 4 would be like this. It would be the same exact shape, just up 4. Down 4 is like this, same exact shape, just shifted down. Left 4 is like this, right 4 is like this. Reflected down is like this, reflected left is like this. Vertically stretched is like this, vertically squished is like this. That's what transformations do. It's basically just having the ability to move the function around. left, right, up, down, flip it over, flip it left and right, and distort the way that it looks. So let's go through a ton of examples. We're going to go pretty quickly though. If I'm going too fast for you, just feel free to pause and get caught up. So here we go. In every case, I'm going to give you the parent function here in black, and I'm going to draw my new function in red. So here we have a quadratic. It's already in vertex form. If you're aware of what vertex form is all about, in this form we have y is equal to a times the quantity x minus h squared plus k, where h and comma k is our vertex. Alright, the vertex of a parabola is essentially just the min or the max, right? It's where it turns. Alright, so the vertex in this case is 1, 5. So this thing is shifting right 1 unit and up 5 units. Right 1 and up 5. I should have drawn a little better graph for this, but right 1 and up 5 is up here somewhere, so it's going to be something like that. Same exact shape, just shifted right 1, up 5. And I know it's right 1 because the number inside here is minus 1. Right? Remember, when they're inside, it shifts left and right. So that's right 1 and up 5. Let's keep going. Number 2. Another quadratic where we have our a term now is 2 and our vertex is -3, -1. So this is shifting left 3 and down 1. And it's also being vertically stretched. Now keep in mind, a vertical stretch is the same as a horizontal compression, but I usually like to talk about things in terms of their vertical distortion. Alright, so this thing is going to be, well, first of all, let me start by saying, if it were just y is equal to 2x squared, it's vertically stretched, so it's going to look like this. Just going to be skinnier, basically. So imagine that somebody's grabbing these two and they're just pulling them up higher. But this one is not just 2x squared, it's 2 and then this whole business where we move left 3 and down 1. So our new vertex is down here, and it's not going to be exactly the same shape as this, it's going to be slightly skinnier. So there you go. Number 3. So now our a term is a fraction. Our a term is a fraction, so that's a vertical squish or compression. It's going to basically just squish it down. So normally it would be something like this. That's basically y is equal to 1/2 x squared. It's squished down. This one's also translated right 5 units and up 3 units. Now when I say translate, that's one type of transformation. Translation is just a shift or a slide. Okay, so this is going right 5 and up 3. So let me get this out of here, and I'll also move this over a little bit. So we're going to go right 5, which is over here, and then up 3, which is like right here. So there's our new vertex, and it's going to be squished down. So it looks something like that. I guess I should have made my graphs a little bit bigger, but we're moving on anyway. Hopefully you're catching on to this stuff. Another quadratic. All right, this negative out in front reflects it down over the x-axis. So it's flipped down, basically. Moving right 8 units and down 1. So if I bring this over here, that's our parent. If we go right 8 units, it's over here somewhere, and then down 1, it's like right here, and we're reflected down. So it's something like that, where your vertex is 8, -1. Number 5, we're switching gears. We're going back to our root function. All right, this is a number out in front that vertically stretches. It's a vertical stretch of our parent function. All right, so what we're going to do is, if we, in red, if we plug in 1 right here, 3 times the square root of 1 is just 3. So you can see how much the new function is stretched vertically. Okay, other than that, it doesn't change, it doesn't slide or flip over. But when we change that first term to a number less than 1, it squishes. Fancy way of saying that is it's a compression. It's a squish. So 2/3 is going to look something like this. Just squishes it down. Number 7. And again, if I'm moving too fast, just feel free to pause and kind of get caught up. But I have like 15 or 16 examples that I want to cruise through. So here we have -4, that's a right 4, and then down 1. So right 4 and down 1, it'd be over here, and then it would look the same otherwise. We ended up skipping number 8 because I just didn't like the function. So we'll jump right to number 9. It's a cubic, and I've got the same deal, right? Anytime the inside stuff sort of changes, that means we're going left and right. In this case, it's a minus here, so we're going to go right 1 and down 4 units. So I sketched my parent cubic function right here. I'm going to go right 1 and down 4. So now it doesn't look anything different except for the fact that it's just translated. So this function basically just moved right 1 and down 4. Number 10. Absolute value, parent function is right here. So this guy, I've got a +4 outside of my absolute value. Looks like it's a -4, but don't be confused, it's a plus. Sorry about that, that was the bell. And I've got, so that means I'm moving up 4, and this thing is flipping it, it's reflecting it down, and here I'm moving left 3 units. So left 3, move this out of here, let's go over here, left 3, up 4, so there's my new vertex, and we're reflecting it down, so it looks something like this. Moving on. So rational function, all right, this is just shifted down 3. It's the same function, just shifted down 3. So this is our normal sort of, it's not the vertex, but it's kind of the origin there where we're dealing with some symmetry. So this one's just going to be shifted down 3, so it's going to look something like this. Something like this. Number 12. All right, same deal here. It's kind of like having it in parentheses, right? That's a left 2. So which means our sort of our origin point is just going to be moved left 2, right? And that's really a question of domain, right? If you can remember some of the domain stuff we've been talking about, x is in the denominator, and the denominator can't be 0. So x plus 2, if it's equal to 0, -2 is the culprit. All right, so that's where we have this vertical asymptote right here. So it's just, this graph is just going to be translated left 2. We have a quartic function. It's left 3, down 2, left 3, down 2. Nothing tricky about some of these once you get the hang of them. And that's not a great drawing, but you get the point. Number 14, some trig stuff. All right, sine of x plus 1. All we're going to do is move all of our points up 1. So we're just going to do, you know, this right here, move up to here. This will move up to about right here, looks like. All right, all this stuff just moving up 1. This is a translation. Pretty basic stuff. And we just kind of connect the dots. Not a great drawing, but you get the idea. Last one, number 15. It's the tangent function. I'm showing one period of the tangent function, and this one is in parentheses, so that hopefully by now you see that we're moving left and right. In this case, it's a positive, so we're moving left pi over 2 units. So this whole thing is just going to shift left pi over 2 units. So it's going to look something like that. That's not a very great drawing, but that's a little better. You get the idea. So there you go. I also talk a lot about transformations in a lot of my domain and range videos. So feel free to check out those. That was a very basic discussion of transformations. Right? I realized I didn't go into a ton of algebra with that. It was basically just, looking at the function rule and seeing how it's changed and following a basic set of policies. And right here, I outlined for you by example what these things do. All right, so just be careful. If it's outside, it's up and down. If it's inside, it's left and right. All right. So I hope you enjoyed it. If you have any questions, ask in the comments, and make sure you subscribe. Thanks for watching.